So you can see my screen, right?
Yes, sir.
Okay.
Yes,
So
sir.
let us recap. Let us recap that what was this thing, right? What was this thing? So initially, so it's easy for me, right? Okay. So yeah. So can you see the blackboard, right?
Yes, sir.
So
Yes,
if I
sir.
want to draw a transistor and biasing, right? Then let us say this is RC, and then this is your transistor, right? So here what I am doing, I'm just connecting two resistance R1 and R2, right? So that the transistor will become self bias. Okay, this is the emitter, right? So what I'm doing, I'm just connecting a resistor called as Re to the emitter. Okay, and then similarly I can draw the equivalent circuit, right? Which shows that yes, the voltage drop across R2, I will represent it by VB. Okay, and yeah, and then RB is nothing but equivalent of R1 and R2, right? As we have seen in voltage divider bias, right? Yes, no, do you remember in the lecture we have
Yes,
seen?
sir.
Okay.
Yes,
Yes,
sir.
sir.
So again, then Re and RC is there, and then this is plus VCC, right? So VBB, I can write it as R2, voltage drop across R2, and it is your R2 upon R1 plus R2
Art.
multiplied by applied voltage VCC, right? Similarly, RB is nothing but your equivalent, right, of R1, R2 upon R1 plus R2, because both are in parallel, right? Now let us say that the current flowing in a base is IB, right? And let us say current flowing in base is IB, and then current flowing in current collector is IC, right? And let me take the output voltage at collector terminal, that is your V naught. Okay, and then what I will do, to this circuit I will just apply the external power supply, right? So the signal which I need to amplify. Okay, so what signal we need to amplify is nothing but your AC signal. Okay, so I'm representing it with this, right? So this sine wave. Okay, so this AC signal we need to amplify. Okay, so what is one kind of explanation which I have given is that this will get superimposed on this IB, and we know that relation between IC and IB is IC is equal to beta times IB. So I can say if IB increases, IC will also increase, right, but with the factor of beta. Okay, so your current input will get multiplied by beta times, right? So I can say that your BJT is working as a common emitter amplifier, right? And if you want to give right output, right, then output is taken between this terminal and ground. Yes, no, correct?
Yes, sir. Yes.
Okay, okay. And then, this is your, I can say that your output equation can be, I can write VCC is equal to some voltage will go get drop across RC, that is ICRC plus your output voltage, right? So from here, I can get the output voltage, that is V naught is nothing but VCC minus ICRC from this equation, correct? Yes,
Yes,
no?
sir.
Okay, okay. So this we have seen, and after that, we also know that IC is nothing but beta times IB, right? Now here, if you see the output equation, then VCC is a constant. Similarly, RC is also constant. So we conclude that your output depends on the IC, right? So if VCC is constant, RC is constant, right? Your V naught is dependent on IC, but there is a negative sign, right? So what this negative sign indicates is that there is 180 degrees phase shift between the input and output, right? Okay, so what is this thing means that if you are giving input as a sine wave, output will be sine wave, amplified version of the sine wave. For example, input sine wave, the frequency is or let us say the amplitude, peak to peak amplitude is 10 millivolt, right? Then your output peak to peak amplitude will be 100 millivolts, right? But what will be the difference? The difference is that if means let us say that one more example, if input is 5 volts, output will be 50 volts, right? But what is the difference is that 180-degree phase shift is there between the input and output. इसका मतलब ये है कि if you observe the first cycle, if there is a positive cycle in the input, then there will be a negative cycle at the output, right? It indicates that there is 180-degree phase shift between the input and output, right? Or you can just compare the first positive cycle of both the signals, right? So you can say that output is displaced by 180 degrees, right? Now one more thing, right? Now what is this? This is your amplifier, right? So what happens, in amplifier, if in the input a direct current is going in the input, right, in the transistor, then what happens, that direct current will also get amplified, right? ये मैंने बताया था आपको, correct, in the theory? Yes, no?
Yes, sir.
Okay.
Yes, sir.
So for that, what we
Yes,
are
sir.
using, we need to filter, right? So for that, we are using a capacitor, because we know that capacitor is the element which will block DC signal and it will allow only AC signal. Now my intention is that only the AC part should get inside the transistor so that it will get amplified, right? So this capacitor is called as your coupling capacitor, right? And we are using two coupling capacitors, right? That is CC1 and CC2, right? Similarly, why these capacitors are there? This will allow only AC signals to pass through it, and the DC part will get blocked. Okay. Similarly, at the why we need at the output also, because if there is a DC supply which we are giving to bias the transistor, so if some component of that supply, DC supply, will get in the speaker, right, or if it gets in the output, right, again there will be some distortion or noise. So that's why we need to block that also. So that's why we are using two coupling capacitors, that is called as your CC1 and CC2. Okay. And then next thing is that, yes, what happens, this current, right, which on which our AC signal is also superimposed, right? So that current IB, right? So now this current which is going inside the transistor, that is AC plus DC current, and IE is nothing but IC plus IB. So in RE also there will be two components which are flowing, that is your AC component as well as DC component, and then this RE will provide a feedback path to the current, and then this AC plus DC will go inside the transistor, right? That will again cause a distortion and noise kind of thing. So that's why we need to we have to what we can say, neglect the not neglect, or we want to avoid giving the feedback from the RE to the input of the transistor, right? So for that, what we are doing, we are just giving a bypass capacitor, right? So what this bypass capacitor will do, it will just bypass all the AC components, right, which are flowing through the emitter, right? So AC components will flow through the capacitor and it will go in the ground, right? And it will avoid the feedback path, right, to the input of the transistor, and hence we can prevent the transistor from getting the distortion, right? So similarly, in the equivalent circuit also, I can just say that what are this CC1, CC2 and CB, right? So both are the same circuit. One is the actual circuit on the left hand side, and second is the virtual circuit, right, which I have drawn it for your explanation, right? That is also called as your equivalent circuit, right? So any difficulty in this so far? So this is your BJT as an amplifier, a quick revision what we have learned in the theory class. Yes, any difficulties, anyone?
No, sir.
No, sir.
No,
Okay.
sir.
So now can we say that yes, the BJT is working as an amplifier and it provides 180-degree phase shift? Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay. Now the same circuit we need to implement, right? Now if you check your Google Classroom, right? I have uploaded there the write-up of experiment number 7, right? Can you see this thing on the Google Classroom?
Yes, sir.
Yes,
So,
sir.
so the write-up contains the same thing, right, which we have covered in the theory, right? So I will just okay. And now can you see the write-up? I'm just maximizing it.
Yes, sir.
Okay, okay.
Yes, sir.
So the thing is that yes, these things are there. So name of experiment is your measurement of transistor amplifier gain in the common emitter configuration, right? So we need to measure the amplifier gain. What is amplifier gain? What is
Beta.
gain basically? No, no, no. what is gain? Output upon input, right? So there is in common emitter configuration, what is the gain? Beta. What is
Beta.
that beta? Which gain?
Current gain.
Current gain, right? So we need to measure here voltage gain. So what is voltage gain? Output
The
voltage
output
upon
upon
Up.
the input.
very good. Output voltage upon input voltage, right? So that is our aim, to measure the voltage gain of the transistor, right? Common emitter configuration amplifier, right? So yes, so we have seen its theory properly in the class, and we had a quick revision, right? Now these are some datasheet specifications of the transistor. For example, if you are using BC456 type of transistor, then these are the symbols, and its outputs are given, right? For example, you know what is VCBO or VCEO? Yes, voltage from collector to base
Collector
when
base.
emitter is open, right? So all these terminologies we have seen, right? Correct.
Yes.
And
Yes, sir.
these are some of the more parameters of your transistor, right? So yes, now we have seen the working of the common emitter configuration. So can we say that this is the same diagram which we have seen?
Yes, sir.
Correct. R1, R2 is there, RC is there, RE is there, and then coupling capacitor 1 is there, coupling capacitor 2 is there, and this is your bypass capacitor. We have named it as CB. Now here it is CE. So not an issue. Okay. Yes.
Yes, sir.
Yes, sir.
Okay. Okay. So AC signal is there. So from where we need to give the input? AC in the actual circuit in Tinkercad, we will give the input from the generator, right?
Generator.
Function
Yes.
generator. Okay. Where we can observe the output on the oscilloscope. Correct.
Yes, sir.
Yes. Okay. Okay. Now let us see something, right? So the coupling capacitors, and we know that thing, right? And this is your voltage gain, output voltage upon input voltage, that we can see. Okay. Now this procedure is, we need to draw a circuit on Tinkercad. After that we need to apply the voltage, maybe 10 volts or 12 volts, and then we need to apply a simple signal, right, which is of 50 millivolts peak to peak, and then frequency is 1 kilohertz. And then we observe the output signal on the CRO, and we can calculate your V output, right? And then we can calculate the gain by this formula, V output upon V input, right? And then we need to record the reading from 50 millivolts to 1 volt, and then we need to draw the input and output graph, right? So that's it, right, guys? This is very simple observation table. Just have the value of input, output, and then gain, right? So what's difficult in this is only the construction of the circuit, right? So let us have the circuit, right? We can construct the circuit on Tinkercad. Okay. So shall I give you the demo how to do the circuit?
Yes, sir.
Yes, sir.
Yes, sir.
So let me start Tinkercad, and then I have logged in directly because I was having a login here, and then I can go in circuits and I can create a new circuit, right? As we have seen. Okay. So first of all, okay, I can use breadboards also. I can use breadboard also, but for simplicity, I will not use breadboard. Okay, I will just prepare the circuit, right? Because you will understand, and then what I expect you to do it on a breadboard so that you can understand all the connections, right? So first of all, which is the main component we want? We want a
BJT.
this transistor, right? You can do parallelly with me. Okay, you have to do. So it is NPN or PNP? NPN, right?
NPN.
NPN.
Okay, so this is your base, this is collector, and this is emitter. So I will just rotate it according to my convenience, right? Emitter, okay, and then what we want? We want resistors, right? So just check it out whether I am connecting it properly or not as per the circuit diagram. So this is your one resistor R1, this is R2, this is RC, and then this is RE. Is it correct? Okay.
Yes, sir.
And this is connected
Yes.
here, and from here one terminal is connected here. So I am not able to connect a terminal here, right? Yes. Okay. So
Okay, sir.
I may need a breadboard, right? So let me have a breadboard. So let me connect a transistor in such a way. Okay. So now let me connect it like this. Is it okay? Transistors, I will just connect it here. Okay. Okay. I will connect a transistor here. Okay. Now see this is directly connected. Is it connected? Yes. Right.
Yes.
Okay.
Yes, sir.
Now these are also connected. Okay. Now we need to connect this with this terminal, correct? And this terminal with any of the terminal. Okay. So I can just connect this terminal to here. Is it okay? If I connect it here, yes or no?
Yes,
Yes.
sir.
Yes, sir.
So I can connect it here. Okay. Then these are automatically short circuited, right? Now this we should connect it here. Okay. This is connected. Now what else we want?
Function generator.
Function.
And then generator.
Yeah. First of all, we will give some power supply. Power supply. Let us give a power supply. So this is your power supply, that is plus VCC, right? Isn't it?
Yes, sir.
So plus VCC plus positive terminal is connected here, right? Let me call it as plus VCC. How much volts we want? 12 volts maybe. Negative terminal I am just connecting it to ground. Okay. Because this is ground, correct?
Yes,
Yes.
sir. Yes, sir.
Okay. Okay. So this complete line is connected. You can see the green line, right? When I
Yes, sir.
yes. Okay. And then this is your plus VCC. Okay. Now what we want? We want some capacitors.
Fun.
Okay. Output is taken at which terminal? Output is taken at this terminal, right? Yes.
Yes, sir.
Just a second. Okay. And then let me take the capacitors, right? Let me take the capacitors. So capacitors, where are capacitors? Which capacitor we will be taking? This polarized capacitor. So it is given between the two terminals, right? So let me say this is your negative. Okay. So I'll just rotate it such that this is your negative terminal. So from here I'm giving the input here. Any problem in this?
No, sir.
So let it. I'm just using different colors just to show you the connections, right? Just to show you the connections, to highlight the connections. Else this is not a good practice. Okay. But I'm using intentionally because I want to show you the what we can say connections. So similarly one more capacitor we want, right? So one more capacitor I want, and then this is your positive, right? Again I want positive. So this is this positive terminal terminal, I am connecting it here, right? And here I need to take the output, correct? Yes, no?
Yes, sir.
Okay, and then one more capacitor I will be taking here, and it is connected, right? It is connected. Where it is connected, by the way, you know? Now this,
Parallel to RE.
so this is connected here, and then this terminal. Okay, so can I say this is parallelly connected with RE?
Yes, sir.
Yes, sir.
Okay. Now all of you please note down that the value of this resistance, we need to keep it as 50 kilo ohms. How much? 50 kilo ohms.
50
R1,
kilo.
50 kilo.
right? So this resistance is R1, correct? Now this is your R2. What is this resistance? R2. And we need to keep it as 15 kilo ohms. Okay. And then this is your RC, which is 500 ohms. This is your RC, 500 ohms, right? 500 ohms. Okay. And then this is your R, क्या बोलते हैं इसको? RE.
RE.
इसको let me take it as 100 ohms, 0.1 ohms, right? And then all the capacitors will be of 1 microfarad, right? So this is of 1 microfarad, ये भी 1 microfarad का है, and this is also of 1 microfarad. Any problem in this?
No,
No,
sir.
sir.
Okay, okay. And then this is 12 volts. Okay. Now let us take the output voltage, right? Let me go back to the board, and I can tell you that this output, right, whatever output we are taking, we are taking the output across, we are taking the output across some resistor RL, right? Speaker के across output लेंगे ना? Yes, no?
Yes, sir.
Okay.
Yes, sir.
So this is your 50 kilo ohms, this is your 15 kilo ohms, this is 500 ohms, and this is your
100 ohms.
100 ohms, right? And all capacitors are of
1
1
microfarad.
microfarad, right? This is of 1 microfarad. This is of 1 microfarad. Okay. So let me go back here. Okay. So RL जो है, right? RL जो है, that also we can take up of, let us say that इसका जो value है, ये 10 kilo ohms का लेते हैं. Okay. So let me take the value of RL as 10 kilo ohms. So एक और resistor लगाना पड़ेगा. That will be somewhere here, that we can connect to the output, and then this part, right, this will be connecting it to ground, because we are taking the voltage drop across this RL, right? This is your RL, correct? Yes.
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Now how to give the input? By using
Function generator.
function generator, right? So we are giving the function generator, and then this positive terminal, this is your input terminal, this I am giving it to capacitor, correct? So let me give some, which color? Blue. And this is your ground, which I am connecting it here. Is it okay?
Yes, sir.
Okay. So the function generator, how much function we need to give? Let me give 50. This DC offset voltage is 0. Sine wave of 1 kilohertz, and this is 50 milliampere, or we can say 0.5 volts, right? 50 milliamperes means 0.5 volts, or
Yes, sir.
500. Yes, no?
0.5 volts, sir.
0.5 volts, 50 milliampere means, correct?
Yes, sir.
Yes, no?
Yes,
Yes,
sir.
sir.
50 into 10 to the power minus 3, so it will be 0.05 or what?
Yes, sir. 0.05.
right? Okay. So this is the peak to peak voltage I am giving. Okay. Now, where I can see the output?
Oscilloscope.
Oscilloscope. So I am just taking the output at oscilloscope, right? So let me give the negative voltage, negative terminal to ground, because it is always connected, and this we are connecting it to across RL, right? Correct. And let me change the color, which it will make confusion. Okay, so this is your output, correct? Yes.
Yes, sir.
So let me start simulating it. And then there is some problem, right?
Yes.
Why there is some problem?
So that capacitor broke.
Just 1 second. So frequency is 1 kilohertz, right?
So the capacitor broke.
Ah, yes.
So that
What happened?
Capacitor near the function generator.
Capacitor.
Near the function generator.
Ah, what happened?
so when
So
you
that
simulate that, it broke.
just
Ha.
start simulation it's showing. See,
Okay, okay, okay. So what's the problem is that we have just इसका जो polarity है ये मैं reverse करता हूँ. Just connecting it between this, and this terminal is connected here, right? So it will take some time, right? So let us wait.
so what is the reading for oscilloscope?
Yeah, so I'm just trying to get the first, we will just try to get the waveform properly. Okay.
Okay, sir.
20 millivolts it is coming, right? So all the connections are proper, right?
Sir, it is showing like the correct waveform at 1000 microsecond oscilloscope. Instead of milliseconds, I did the microseconds.
Now what will happen of that?
It is showing the correct display.
Yes, but that is again not a proper wave, right?
So 1000.
1000. Okay. So 1000 microsecond if we are taking, right? Uh, can you just calculate the frequency? This is 10 milliseconds, right? So one will be of 1 millisecond. So 1 millisecond का उल्टा कितना आता है? 1 kilohertz, right? Okay, correct. Now the scale is correct. Okay, what is input voltage? Peak to peak volt?
50 milliampere.
50
50
millivolts,
milliamp
right?
volt.
Now I'm just zooming it. How much it is? Can you just guess? So total is 400, right? So one division corresponds to 40 millivolts, right?
Yes.
So how many divisions this is? 1, 2, 3, 4, and 5 divisions, right?
5, 200,
So 5 into 40.
40.
How much?
200.
200
200.
millivolts, right? Correct?
Yes,
So
sir.
input is 50
50
millivolts.
millivolts and
Output
output is
is
200 millivolts.
so
200 millions.
can you, are you getting the voltage gain?
Yes, sir.
Okay.
Yes, sir.
Now let me improve. Let me increase. Right. Let me increase the voltage. Okay. I need to increase the voltage in millivolt. Right. So let me increase it to how much? 0.6. Is it 0.06? Right.
Yes, sir.
Yes, sir.
60 millivolt. So if I am giving it as 60 millivolt, how much it is? 1, 2, 3, 4, 5, 6. So 6 into 40, 240 millivolts. Is it correct?
Yes, sir.
Yes, sir.
So let me go back to the write-up, and then we can see that input, output, and then voltage gain. So for different inputs, just vary the value of input, and you will just note down what output you are getting, and then you can calculate the gain from input voltage and output voltage. Whatever gain you will get, so you can get it on the means you should get the constant voltage gain for one type of configuration. Correct?
Yes, sir.
Okay.
Yes, sir.
Okay. So good. Any problem, anyone?
Not yet.
Okay. Now just see what I will do. Last part, right? Phase shift का रहेगा ना हमारा. So phase shift अगर देखना है हमें, so what I will do, I will just want to see what is the input waveform. Okay. So input waveform के लिए what I will do, I will just connect a negative part here, maybe to the negative. होता है ना ऐसा? Right, and this positive part I will connect it to positive. कौन सा color? Getting what I am trying to get? I am trying to visualize the waveform which is coming from the oscilloscope. Okay, and simultaneously this is your input waveform, this is your output waveform, right? So see, it will take some time for settling down. It will take some time. What happened? Uh, this is connected, right? Is this connected? Yes. I'm not able to see the input waveform, so that's why I was worrying. Let output waveform get settled down, then we can expect input waveform. Input waveform I'm not able to see because maybe the voltage, how much it was? 1000.
1000 microsecond.
Okay. Okay, great. So yes, now just see. Okay, so phase shift you can see only on dual oscilloscope, right? Okay. I just wanted to show you the phase shift. Okay, so we need a what we can say, we need a dual oscilloscope, right? Means on one oscilloscope we can simultaneously see two waveforms, right? If we have that provision, then I can show you the uh, phase shift. Okay. Yes. So for now, is it clear? Experiment number 7. How to
Yes,
do
sir.
the connection,
Yes,
what
sir.
is the circuit, and how it is giving the amplification and all that. Is it correct? So if you have observed, right, we have to do the connections very carefully, right? There is one great advantage of the simulator, that it will give the like if any component is not working properly, नहीं तो देखो capacitor, right, it got that capacitor is bursted, right? So in actual, right, if we do some small mistake also, then maybe your components may get damaged. Okay, so that's why we do simulation first and then we can connect it in a real world. Okay, so I guess that the practical is clear to all of you. Yes, and you can make the circuits, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay, okay. Any difficulties, anyone?
No, sir.
No,
No,
sir.
sir.
No, sir.
Okay, so I will just stop recording and then you can just start doing implementing your circuits.